Bismillahirrahmanirrahim. Assalamu alaikum, dear guys. Mr. Atiq once again here from the science department. We have week 13 in chemistry. In chemistry subject, we are going to cover in the week 13 the pages ranges from 460 to 463. Chapter 14, section 3, it is continued. Okay, we will continue. We discuss different acid bases theories, different sort of reactions and all those things regarding acid bases. So it is continued. Amphoteric compounds. Any species that can react as either an acid or a base is described as amphoteric. What? Amphoteric. Any species that can react as either an acid or a base is known as what? Amphoteric. Any species, okay, which can react with the acids or bases are known to be what? Amphoteric. Example is water. Consider the water. Simple example. Water can react as a base. H2SO4 sulfuric acid. This is an acid. Combined with the base H2O. Look at acid bases. It will give us what? Acid H3O. Though it is an ion. Okay. H3O. HSO4 negative, it is a base. So it clearly indicates that the species, like the water, that reacts either to become like with the acids and bases like this. Okay, are known to be amphoteric. Amphoteric compounds, they are continued. Let me to remove this sign. It is continued. Branch OH in a molecule. OH, hydroxyl ion, hydroxide, or you can say HOH. Branch. This arrow means branch. Okay. The covalently bonded IOH group in an acid is referred to as hydroxyl or hydroxyl group. Molecular compounds containing branched OH groups can be acid or amphoteric. The behavior of a compound is affected by the number of oxygen, of course, atoms bonded to the atom connected to the OH group. Remember this thing, okay? How you people will identify the amphoteric compounds? From this OH, okay? If this is attached, we will call them what? Like hydroxyls as well. And this is the main sign for the amphoteric compounds. Oxyacids of, let's write combine. Oxyacids of chlorine. Oxyacids of chlorine. Now look at chlorine, but in different form. Look at HOCl. Look at hypochlorous acid. Single O. Hypo. Mono as well. Okay, remember. Chlorous acid. What? Chlorous acid, in which two oxygen atoms are involved. For example, this one considered to be the hydrogen or chlorine, and this one is considered to be the hydrogen and chlorine as well. Suppose this is hydrogen, this is chlorine. Now these two are what? Oxygens. Okay, look at the acidity increases. Okay, hypochlorous single, chlorous double O, oxygens. Chloric, 3 oxygens. 3 oxygen. 1, 2, 3. Look at the structure. Consider this is a chlorine, and this one is considered to be the hydrogen. Perchloric acid. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. Look at 1, 2, 3, 4. The reddish bubbles. Okay. They're considered to be the oxygens. So look at how the acidity increases. Hypochlorous acid, chlorous acid, chloric acid, and perchloric acids. These are what known to be the oxy, like how the oxygen differentiate the acids, okay, of chlorine. Chlorine is there everywhere. One, look at here, chlorine as well, here chlorine as well, and chlorine as well. But the oxygen, how it affects the acids to change the form of chlorine. So 1, 2, 3, 4 oxygens respectively. These are what? Oxy acids of chlorine. Now, neutralization reactions. Strong acids, strong base neutralization. In aqueous solution, neutralization is the reaction of hydronium ions and hydroxide ion. In aqueous solution, neutralization reaction is known as what? Neutralization reaction is the reaction of hydronium ions, remember, and the hydroxide ions to form water molecules. To form what? Water molecules. Now look at an example. A salt is an ionic compound, of course, NaCl, consider it. Compound composed of a cation from a base and an anion from an acid. A salt is an ionic compound composed of a cation from a base and an anion from an acid. HCl combines with the NaOH. So NaCl, like what? The salt and H2O liberation, the water they will produce. So this is what neutralization reaction, the reaction between hydronium ion and hydroxide ion. Remember, acid rains. Now this is the most destructive one. It can kill the stones, okay? Acid rains, remember. NO, NO2, CO2, SO2 and SO3 gases from industrial processes can dissolve in atmospheric water to produce acidic solutions. SO3 plus H2O combines, they form what? H2SO4, the acids. Examples: very acidic rain is known as acid rain. Acid rain can erode statues and affects ecosystem. Destructive one: erode statues made from stones and different kinds of precious stones. Acid rains, when it falls, okay, it will erupt it will erode, like erosion, understand, and it will affect the ecosystem as well. Now look at, we give you a statue, look at this, it's been eroded, look at all the holes are here, eh? Look at the shape's been all destroyed. This is because of what? The acid rains. So acid precipitation, look at, okay, after many years the acid rain will affect, because usually in the Europe, and you can say like in America and Canada, the statues are there, so, and the rain percentage as compared to the Gulf and the Asia, there it is quite heavy, okay. Or on regular basis, like after 24 hours, 36 hours, like the period or the span, the rain span is just so low, that's why. Understand? Look at this, is the acid rain effect, acid precipitation. So this is the end of chapter 14 show. Kindly study the sheets for the online test. They are already provided to you guys, and we will meet next week inshallah. Thank you so much.